All right, in my last video, I showed you how to find the slope of a line when you were looking at it. And the idea was that you would find two good points, and then using those two good points, you would count the rise and the run and use that to find the slope. Well, in this one, I'm not going to give you a graph. You're going to be given 2 points, and you have to find the slope. So let's remember some things about slope. First off, we remember that slope is rise over run. And if you think about a graph, what is the rising axis? Which axis on a graph, right? Here's a graph. Which axis is the up and down axis? Well, that's the y. And which axis is the running axis? That's the x. Oh! There, the lights went off. Okay. Sorry about that, lights went off. So, slope is actually, can be well, first off, slope, we remember the variable that we use for slope, this m. Let's keep that in there. But slope can be thought of as y over x, or the change in y over the change in x. So keep that in your head. And remember, if you don't like this method that I'm about to do, you could always graph these things and calculate the slope using graphs. So you could graph it. You could graph the points and find the slope. That's an option. That's a great option. I'm not going to use that option, but it's a great option. Or you could use the equation, and here's the equation. Slope, which is m. Let's zoom in on this a little bit. This is a great equation. Slope, which equals m, is the change in y. It's the second y minus the first y over the change in x, which is the second x minus the first x. Now, how do I explain this? It doesn't matter which point you choose as the first or second, as long as you stay consistent. I'll show you this. Ready? Here we go. We're going to do an example. Find the slope of the line that passes through 8, 6 and y and 4, 1. Let's say that this is x1, y1, x2, y2. And if you had wanted to call this point 2, that would have been fine, and this point 1, as long as you don't switch them up within the point. Now let's use the equation. Ready? I need y2, and I'm going to put it right here. y2 is 1. I need y1 is 6. I need x2 is 4. I need x1 is 8. I'm plugging the numbers into this formula, and here it goes. Ready? 1 minus 6 is -5 over 4 minus 8 is -4. The slope of this line is 5/4. There it is. The slope of this line is 5/4. And if I were to plot this thing, I would see the exact same slope. Ready? I'm going to try to plot it. This is going to be really weak, but I'm going to do it. Okay, 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 4, 1. 1, 2, 3, 4, 1. Okay, ready? There's my line. My rise is 1, 2, 3, 4, 5, and my run is 1, 2, 3, 4. 5/4. I could have plotted it, but I'm going to start using this equation, especially when my numbers get really large. That equation is going to be critical. Okay, let's do another one. Remember that equation. This is your equation. This is the magic equation. Ready? Magic equation. Magic equation. Magic. Magic. Okay. Keep that in your brain. Okay, we're going to find the slope. Here are 2 points. x1, y1, x2, y2. This is going to be magic equation, magic equation, magic equation, magic equation. Singing math teacher. Okay. y2 is 18 minus y1, which is 9. x2 is 1 minus x1, which is 8. 18 minus 9 is 9. 1 minus negative 8 is negative 7. That's my slope. I don't like having that negative down in the denominator, so I'm just going to push them up to the top. Write this as negative 9 over 7. That is the slope of this line. Hopefully that is correct. Negative 9 over 7. Yes. Here's another one. And okay, could you have plotted this one? That 18 is getting a little bit big on you. But you could have plotted this. Now this one, do you really want to plot 60, 5 and negative 3, 89? No, you want to use the equation. Here we go. Magic equation, magic equation, magic equation, magic equation. Here we go. x1, y1, x2, y2. y2 is 89. x2, no, y2 is 89, y1 is 5. x2 is negative 3. x1 is 60. 89 minus 5 takes me to an 84. Negative 3 minus 60 takes me to a negative 63. Is this reducible? Is this reducible? 89. Why do I think this should reduce to something? 63, 7 and 9. If it can reduce, reduce if possible. Let's see, what is 84? That looks like it's a 4 times a 21. There's a 3. There's a 3 floating around in this thing. There's a 3 here, people. There's a 3. This reduces by 3, doesn't it? 3 goes into that. 3 times, okay. 21 times 4. 28 times, is that right? 84, 3, 2, 6, 2, 4. Okay, so this turns into 28 over 21. That reduces even more, doesn't it? I know I'm spending all this time reducing a fraction. Okay, that reduces more. This goes, 3. This can reduce by 7. 7 goes into this 4 times. 7 goes into that 3 times. There we go. Negative 4/3. Reduce if possible. Reduce if possible. Okay, that's it for that one. Thank you for watching. Bye-bye.